Bismillahirrahmanirrahim. Okay, so let's get started. This is this is going to be lecture number 6, uh, and in this lecture, like we are going to continue our discussion of functions. I guess this is what we talked about in our last lecture. In our last lecture, we uh, talked about computations and different types of computations that computers can perform. We have talked about computations before. We called computations as data processing. So anything that you use, anything that the computer does to process data, that is called computation. So we talked about it, and then we briefly mentioned what are algorithms, what are abstractions, how and what are data structures. So how do these things help in performing computation? So these are the different things or different tools that computers or computer people who are using computers, computer programmers, they use in order to specify or do computations. We also talked about language constructs or ideas. So C++ is a programming language, and just like any other language, it gives you constructs or features, language features that you can use to express ideas. We said that normally for example, one very trivial and very important language construct is that all the instructions are executed in a sequential order. Okay, so when you specify instructions, they are executed as if they were in a sequence. So the instruction that you specify first, that will be executed first, followed by the next one, and the next one, and the next one. Okay, and those instructions can have expressions and other statements, and similarly, we can do selection among different statements or blocks of code. So we can select the execution of one block of code subject to a certain condition. If a certain condition is true, we can select one block of code and execute it. If that condition is false, so we can select another block. Okay, so if you remember the if structure, an if else structure, and if else if structure. So all these structures, they are basically selection structures. They allow you to select different blocks of codes for execution. Then we talked about iterations. So we talked about the while loop and the for loop. Both these loops, you use these loops for iterating over a block of code. So if you want to repeat the execution of a block of code, if you want to execute a block of code again and again, so you can use iteration. And for iteration, we talked about the while loop and the for loop. So the while loop executes while a certain condition is false or until that condition becomes, sorry, while a certain condition is true or until that condition becomes false. Whereas the for loop, it is a purely counter control loop. So you specify a loop counter, you initialize it with some initial value, then you specify the termination condition or the condition for continuation of the for loop, and then you specify a way to change or modify the loop counter. So we talked about that in much detail. Then we introduced the ideas of functions. So functions are basically blocks of code that perform a specific computation. So you write functions because the computation that you perform using that function, it is logically separate. Like you can perform it separately from other computations, and usually that computation is required more than once in your program. Okay, so for example, we have used built-in functions or library functions. So we have used the log function, we have used the square root function, we have used the power function. So all these functions, they perform a specific computation, and usually you require these computations more than once in any program. So that's why it is a good idea to write a separate block of code that does only that, that performs only that specific computation. In this particular lecture, we are going to further expand on our discussion of functions. That comes at number 3. But before that, we are going to talk about some language technicalities or language features. Some of it we have already talked. Most of it would feel like a repetition, but at this level, repetition is a good thing. So we will be going through all these things in a more formal way and in a more accelerated fashion. and then we'll also talk about functions in more detail. So in our last lecture we just briefly introduced the idea of functions and how to write functions. Here we will go into a couple of here we'll go into technicalities of writing functions, especially with respect to passing arguments. So if we pass arguments or inputs to a function, so what are the different ways in which we can do that? So we'll talk about that, and while doing that, we will introduce the concept of values and references. Okay, so we'll talk about that, like what do we mean by values and references. Before that, like we will again talk about the notion of declarations and definitions. We have talked about that, especially in the context of functions. We said that like a function prototype, for example, we said it declares a function. It tells the compiler what is that function all about. Okay, so it basically does that, and then we define that function. We wrote the body of code for that function, so that is a definition. We will differentiate between these two here again. We briefly mentioned namespaces before. We will clarify the concept of namespaces with a small example. Okay, so let's get started with today's lecture. So language technicality is like why do we have to worry about so many things in any programming language? So language technicalities or the syntax or grammar of a language, it is kind of a necessary evil. So just like any other language, a programming language is a foreign language, and when you're learning a new language, you have to learn the grammar and vocabulary of that language. So if you're learning a new language, you need to know the vocabulary, and you also need to know the grammar, how to put those words in sentences so that you can communicate with other people. Okay, so this is important, and this is particularly important for computers. Why? Because programs must be precisely and completely specified. So you have to specify a program precisely, like what do you want exactly, you have to specify that, and you have to be able to specify it completely. Computers, unlike the common perception, they are not intelligent machines. They are very stupid and very dumb machines, and they are very fast machines. That is their quality, but they are very stupid. So you need to clearly tell the computer what it needs to do. Okay, so you cannot let a computer guess for you. Okay, so you should basically specify whatever you need the computer to do in a very clear way. So that is why we must know the rules and the grammar and the vocabulary of a language. Okay, so it may not be possible to learn all the rules. For example, the C++ 14 standard, it is around 1350 pages. So that is quite a lot, but you need to know some of the rules, and you need to be able to use the programming language effectively. While learning the language technicalities, we must always remember that we are studying programming, and we are not just learning the language. The language, it is important to learn the language to do programming. So if you learn the language and you're still not able to do programming, then it's no use. So as programmers, your output is programs or computer systems. And in order to produce this output, you use the language as a tool. So you should know how to use the tool, but you should know how to use the tool to do the actual job that you're supposed to do. Okay, so this is also important. You must know that. So do not spend a lot of time on minor syntax and semantic issues. Syntax is related to grammar, and semantic, whenever you hear the word semantic, that means meaning of any particular statement or things like that. So do not spend a lot of time there. You should know, like you should be aware of the very basic syntactic issues or basic syntax, but there are always more than one right ways to do things. Just like there are more than one ways to say things, there are more than one right ways to do things in programming. Okay, Similarly, most design and programming concepts are universal, or at least very widely supported by popular programming languages. So whatever you learn in C++, you can always use this knowledge in other languages as well. So it is not like you're just learning C++. While learning C++ and while learning the design and programming concept in C++, you're basically learning other languages as well. Okay. Similarly, language technicalities or syntax that is also common among certain languages. Okay, for example, Java, C, C Sharp, and C++. They all have a lot of common technicalities, a lot of common features or common ways of doing things. So if you learn certain syntax, for example, the for loop, it is exactly the same in C and Java and C++. Okay, similarly, the while loop, similarly, the way you declare variables, the if else structure. So, all these things, they are exactly the same in all these three languages. So, if you learn it in one, you can always use that knowledge in other languages as well. Okay, so let's start with different types of technicalities. The first thing that we will talk about is declarations. We have talked about that. You know what a declaration is, okay? So here we'll talk about it in a more formal way. And here we will introduce some more terms as well, and you need to understand those terms and know their meaning very clearly. So you've done these declarations, okay? You've declared variables, you have initialized those variables. So this is a declaration as well as an initialization. We have also declared a constant variable. For example, I guess we declared a constant variable centimeters per inch or something like that. So this is a constant variable, and this is the function, a function's declaration. Okay, this is a function declaration. We called it a function prototype as well. So you have done declarations. Here we'll talk more formally about declaration. What is a declaration? A declaration introduces a name into a scope. A declaration introduces a name into a scope. Okay, so this is a name A, and this declaration introduces, what is this name A? What is A? A is an integer. Okay, so A is an integer, and here we use the word scope. Okay, so a declaration introduces a name into a scope. So you should know what a scope is. A scope is a technical term. You should know that. What is a scope? A scope is a specific region of the program. Okay, a scope is a specific region of the program. For now, think of it as a block of code. So any pair of curly braces, think of it for now. It may not be a very good definition. So you can think of it as a scope or a region. Okay, so it has any pair of curly braces. It defines a specific region of your code or a scope of your code. Any name declared in any declaration in that scope basically introduces a name into that scope, into that block of code. Okay, and usually that name is visible in that block of code, and outside that block of code that name is not visible. You cannot access it outside that block of code. Okay, we'll introduce different types of scopes. For now, you can think of it, these two would be more important. One is local scope, and the other is global scope or file level scope. Okay, so local scope is a scope that is restricted or limited to a particular block of code, and global or file level scope, it is when you declare a name, when a declaration is at the level of file outside any function. Okay, outside any function, outside the main function, outside any other function that you might have defined. So that declaration is then basically for a global variable, or that declaration is global. So that name which is introduced by a declaration at the file level outside any function, that name is visible in all the blocks of code in that file. Okay, so it is kind of a global declaration. So we'll look at a couple of examples and know about these things. A declaration also specifies a type for the named object. So whenever you introduce a name or a named object, so you should know what an object is. An object is anything that occupies space in memory. So a declaration basically introduces a named object into a scope, and it specifies a type for that object. Okay, so int a is equal to 7. So a is a named object. Why? Because it is assigned or allocated RAM space in RAM, and it has a type. So a declaration introduces type for that object as well. Sometimes a declaration includes an initializer like this. This is a declaration as well as an initialization. But this is not always the case. Okay, so it may not, a declaration may not always include an initializer. A name must be declared before it can be used in a C++ program. This is a universal rule that you should always remember. Whenever you want to use a name, okay, you must declare it first. Before declaring it, you cannot use a name. So once you declare it, then you can use it. Okay, that is why we need to write function prototypes. Okay, function prototypes, they serve as declarations. So usually we place function prototypes above the main program, and usually we define our functions after the main program. Usually that is how it is. Okay, so if you do it this way, so you need to have the function prototypes. They basically tell the compiler, if you are calling that function from the main program, the function prototypes basically tell the compiler like how this function can be used, like what is its return type, and what type and number of arguments does this function need as input. Okay, so declarations, you should know about declarations. We have used this. This is just a more formal introduction to declarations. Declarations are frequently, again, we briefly mentioned, talked about it in our discussion about like what are header files and why do we have these hash include directives at the beginning of almost every program. So this is why we have these. Usually, when you're writing and when you're working on large programs or big projects, so what we do is we put all the declarations of variables and functions and constants, all these declarations, we put them into a file called headers or header files. Okay. So for example, IOStream is a header file. CMath is a header file. Okay. String is a header file. So all these header files, they include declarations of constants and variables and objects and functions. Usually these headers are for a particular library. So all the functions and constants and variables or objects declared or used or a part of that library, so those declarations are put in a single file. Okay. So declarations are frequently introduced into a program through headers. So when you include a header file, basically you're including declarations in your file. The contents of the header file are copied into your program. A header is a file containing declarations providing an interface to other parts of a program. So headers, they include declarations, and declarations are basically of variables, constants, functions, objects. So they basically these declarations help your program or other parts of your program know, okay, which kinds of functions are available to you and how can you use those functions. Okay, so we are using the word interface here. Okay, so that is what interface is. Interface is basically like what are the functions available to you and how can you use those functions. Okay, so these declarations, they provide an interface to other parts of the program. So when you use, for example, when you want to use the log function, so these declaration, it tells you like how can you use the log function, what is the name of the log function, what are the type and inputs of the log function, and what is the return value. If you want to use the power function, POW function, so how can you use the power function, what is the number and type of arguments, what is the return value, etc. Okay, so declarations, these header files, they basically include declarations. All declarations are put together into one single file. Okay, so when you include a header file, you're basically including declarations. It allows for abstraction. You don't have to know the details of function like cout in order to use it. Okay, abstraction is, okay, you hide the underlying details and you just use the functions or the interface. ठीक है ना? Just for example, if you are working with a TV, so the TV provides you with an interface. There's a power button, there is an increase or decrease button, and there is a select button or a menu button. So with these 4 or 5 buttons, you can interact with the TV. You can increase its volume, decrease its volume, increase the brightness, contrast, and all these things. Tune different channels. You don't need to know what happens behind the screen, what goes on inside. So with the interface, you can just interact with the TV and get your work done. Okay, so that is the idea about declarations. Declarations, they provide you with an interface or abstraction, an abstract layer. You don't need to know the details of the functions or the working of the functions. You just know how to use them. That is the only information that you need to know in order to use them. And declarations provide you with this information कि ये जो फंक्शन है इसका नाम क्या है, इसको आपने इनपुट क्या देनी है और ये आपको आउटपुट क्या देगा. If you know these things, you can use that function, and that is important. You should be able to use that function. You don't necessarily need to know how does that function work. Okay, so when you write a statement, when you put a directive like this, hash include iostream, so what you do is the file iostream.h header file is located on your hard drive, and all the declarations in this file, they are copied and pasted into your source code. Okay, so then your program, the program that you're writing, it knows which functions are available to it and how to use those functions. Okay, so this is an example. For example, if you write this code, int main, and here we are printing cout f, and within parenthesis I. Okay, so like here we have three names at least. For example, we have cout. We don't know what cout is. The compiler would not know what cout is. This is a function. Okay, so f within parenthesis I, this is a function. Now this function f, it is not known. The compiler does not know what this function is. Similarly, I is a variable. You're passing I as an argument or input to the function f. Okay, so this code would result in at least three errors. Okay, you fix one, you will get another. You fix that one, you'll get another. So you'll have at least three errors in this function, and all these three errors are because of missing declarations. Okay, so you have not provided declaration for cout. What is cout? The compiler does not know. You have not provided a declaration for the function f, and similarly, you have not provided a declaration for the variable I. Okay, this is not a problem. This is a string literal, so it is not that big a problem. But these three names are problems. So you'll have at least three errors because of missing declarations. You have failed to declare these names. So how can you fix this issue? So first of all, you need to add declaration for cout. That declaration is available in the iostream header file. So you need to add this iostream header file. You need to include it into your program. You include this, it will to some extent solve the problem of cout. I said to some extent. Why? Because cout is defined in the namespace standard. So you need to use using namespace standard as well. Okay, if you do not put this statement, you can write it here as std and then the scope resolution operator cout. Then it will be fine. But in order to fix the uh, problem of declaration of cout, you need to include these two. You need to write this statement using namespace std, and you need to provide this preprocessor directive hash include iostream. This will fix the issue or the missing declaration of cout. Now we have two more problems. One is the definition of function fi, sorry, declaration for function fi, function f, and the other the declaration for I. So you need to include declarations for that as well. So this is the declaration of the function f. Function f. So function f is a function which takes an integer value as input and returns an integer value. This is the declaration of function f. We called it as the function prototype, if you remember from our last lecture and in our last lab session. So this is the declaration for function f. And here we declare the variable I. Okay, so we declare the variable I. So this is the declaration of I. Now we have provided declaration for each of these names. The declaration for cout is available. Sorry, we are missing here using namespace std. That should be here. Okay, using name. Let me add it. Using namespace std. Okay, using namespace. Sorry, namespace std. This should be here. Okay, so by adding these declarations, we have fixed all the these two this preprocessor directive and this statement, it fixes the declaration issues for cout. This function prototype or declaration for the function f, it fixes the problem with f, like now it is no longer an undefined or undeclared name. And this variable I, it fixes the declaration issue for I. Okay, so now I is not no longer an undefined name. Similarly, note here, this is the declaration of function f. Declaration, it basically tells the compiler how can we use this function f. So what does the compiler need to know how to use the function f? It needs to know the name of the function, and it needs to know the type and number of arguments for that function. And the return type is also important information. So it has all this information here. But here we have not defined what does this function f do. ठीक है ना? That definition is provided here. That definition is provided here. So here we specify using this block of code what does the function f do. Okay. So this is the definition of function f, and this is the declaration of function f. Okay. So you know all these things. Now let's talk about definition. We want to differentiate between these two terms, declaration and definition. Okay. In the case of functions, it is very clear. This is a declaration of the function, okay, and this is definition of the function. Definition includes the body of the function. Declaration does not include the body. The body of the function specifies what does the function do with the input to produce the output. Okay, and the declaration, it only instructs the compiler how this function f can be used. इसका नाम क्या है, इसके input arguments क्या हैं, इसकी return value क्या है. ठीक है. Now let us differentiate between these two terms, declaration and definition. A declaration fully specifies the entity declared. A declaration, okay, so what is a definition? A definition is basically a declaration that also fully specifies the entity declared. ठीक है, is called a definition. So any declaration that fully specifies the entity that it declares is called a definition. For example, here int a is equal to 7. So this is a declaration as well as a definition as well as an initialization. This is also a declaration and definition. This is a definition as well as declaration and this is also a definition and a declaration. It is not an initialization. Okay, so int b fully defines what b is. So b is an integer. It is allocated 4 bytes in RAM, and it is initialized with some garbage value. It is not initialized, but it has some garbage value there. This is a definition of a function. Okay, this is a declaration as well as definition. So you're declaring the function square root. What is this function? What are its input and output types and number of arguments, and you're defining it as well. You're providing the body of code as well, which basically implements the computation that this function is all about. Similarly, this is a user-defined type, struct. If you want to create a new data type, so you can use structures in C++ to create a new data type. So this is also a declaration. We will learn about it in coming lectures. This is also a declaration as well as a definition. Okay, so a definition fully specifies the entity declared. The entity that is being declared, it is fully specified. What do we mean by fully specified? If you are declaring a variable, so by full specification of the variable, you can think of it as the allocation of space in RAM for that variable. If you are declaring a function, so full specification of the function would include the body of the function, okay, the code that basically implements the computation that that function is going to perform. Acha, here these are declarations without definitions. So this is a declaration. So it only specifies the name of the function, the number and type of input arguments, and the return type of the function. And then there is a semicolon. It does not specify the function body. Here we are introducing a new name, struct point, but we are not specifying its members. So int x and int y are these two members of point. Any point is basically an ordered pair, x coordinate and y coordinate in 2D. So this is a 2D point. Okay. Similarly, we can have variables with external linkage. Okay, so we may not be using extern often, but you may come across this thing. So extern int a means that int a is defined somewhere else. Int a, this variable, it is defined somewhere else in another file. Okay, so it is a declaration and it is not a definition. We may not use it ever, but you should know the difference between a declaration and a definition. So normally when you are declaring variables like these, you are basically declaring and defining them both. Okay. So here if you see in the declarations only example, you will not find statements like these. Okay. These are both declarations and definitions. So why do you have similarly declarations and definitions, some more technicalities regarding declarations and definitions. One is you cannot define something twice. You cannot define something twice. A definition says what something is. So for example, int a, these are definitions. You cannot define a variable twice, the same variable twice. Your compiler will flag an error here. This is the definition of the square root function. Okay, you cannot define the square root function twice. You can only define it once. Okay, within the same scope, you cannot define it twice. You can declare something twice. Now that may be possible. We can declare something twice. For example, we have done it with functions. So first of all, using the function prototype, we define that, we declare that function. Okay, what is the name of the function, the return type, and the type and number of input arguments. And then we define that function. The definition is both declaration and definition. Okay, so when you define a function, you are declaring it as well. So that is why like we can have this declaration of function and this declaration and definition of function together in one file. This is allowed. Okay, but definition twice is not allowed. Like you cannot specify the body of the function twice in a single file. Okay, in a single scope, in the same scope. Similarly, this is the definition of variable a, and this is just declaration of variable a. We specify that this variable, this declaration basically says that this variable is defined in some other file. Okay, here this is declaration as well as definition. So these two statements can coexist in the same file. Okay, this declaration definition. Again, declarations and definitions, or defining something twice or declaring something twice, this would more like you should know that this will not work. Okay, this we are defining or declaring a variable twice will not work. Similarly, defining a function twice in the same scope, this will also not work. This is an error. And declarations, these can work. Again, these differences may be very subtle for you, but it is a good idea that you are aware of these technicalities. I hope you have observed these issues. If you have tried similar things with in your programs or lab sessions, then the compiler must have flagged some errors while you were doing that. So why do we have declarations and definitions? Okay, what is why do we need to differentiate between the two? Okay, to refer to something, we need its declaration. If you want to use something in your program, you don't need its full definition. It needs to be defined, definitely. But if you only have its declaration, that is good enough. You don't need its definition to use it. For example, when you want to use the cout and cin objects and the cmath library functions, you just need their declarations, and you import their declarations in your program by writing those hash include directives. You don't need their definitions in order to be able to use them or in order to be able to refer to them. Okay, often we want the definition elsewhere. Okay, often we put the declarations and definitions separate. One file usually contains the declarations, another file usually contains definitions. Okay, so why do we need to separate? So maybe we want some other person to define it. If you are working for an organization, so somebody might work on the interface, like this is the interface that we need to have, and then different people might be working on that interface कि किस function को किस बंदे ने implement करना है. So we can do that. We can have definition later in a file as well. So that's why we put declaration separate and definition separate. Declarations are used to specify interfaces. interfaces to your own code. Interface से क्या मुराद है? Interface, when you hear the word interface, think of a TV or an air conditioner. So you have the remote, the TV remote, and the air conditioner's remote, or the buttons on the TV, or the buttons on some other device. That is the interface. You interact with that device or appliance using that interface. ठीक है? So you don't necessarily know how each functionality is implemented inside. For example, जब आप किसी चीज़ को माइक्रोवेव से गर्म करते हैं, so you don't necessarily know what goes on inside the microwave. How are the microwaves generated, and how do these microwaves then heat up the food or any other thing that you put inside the microwave. You don't necessarily know that, and you don't necessarily want to know that. All you need to know is how to use the microwave oven. Okay, so interfaces. So all you need to know how to use the interface. That is important. So interfaces to what? Interfaces to your own code. So part of your code might be using some functions. ठीक है? So so your program should also know कि आपके प्रोग्राम में और ऐसे कौन से फंक्शंस मौजूद है जिनको आप इस्तेमाल कर सकते हैं. And libraries, ठीक है? Interfaces to libraries. So libraries are key. We cannot write all the code that we need by ourselves. So and we shouldn't be trying to do that. So people have written created code libraries. We can always reuse those libraries, and in some cases we can try to improve those libraries and then put out those libraries for use by other people. ठीक है? So declarations are useful as they specify interfaces. In larger programs, if you're working with bigger programs, what we do is we place all the declarations in header files, and that helps in sharing our code or interfaces as well. Okay, so in the next in the course that comes after this one, the course on object oriented programming, we basically you do multi-file programming. So we put our declarations in a header file, and then we put the definitions in a separate source file, and then in the main program we use those declarations and definitions in some way. So I'll give you just an example, like how do we do that. uh, for example, here. Okay, so this is how we do it there. So for example, this is a header file token.h. ठीक है ना? So here we put all the declarations. Here we put all the declarations. So you may not be aware कि ये क्या चीज़ है. So here we are basically creating a user defined type token, and we are doing it by using classes. So here we have all the declarations. Now these declarations have declarations for constants and declarations for variables and declarations for functions. So in order to implement these, define these functions, we create a source file token.c++. So token.c++ imports these declarations using this statement hash include token.h, and then it provides definitions for all the functions defined in this header file. Okay? And when we want to use these functions, so for example, this program, this source file, this is our main.c++ or any other C++ source file, and we want to use these functions, so we include these declarations. Okay? So when we include these declarations, so their definitions are automatically accessible to us, and we can use these functions. Okay? So this is how we do multi-source, multi-file programming. So we declare, we put all the declarations in a header file. We define functions in this header file in a separate source file, and this is the program, or this is the source file where we use these functions. So we include this header file here, and then we are able to use these functions. So usually that is how we do programming there. Okay, so kinds of declarations that we have done so far. So we have declared variables, like you have declared integer variables and float variables. This is a declaration as well as a definition. We have declared constants. Okay, so const int x is equal to something. So we have declared constant variables. Here in this program, say for example here, const double s, and we are initializing it with this value. This is called to a function square root. So we are initializing s with the square root of 2. Okay, and this is a constant double value, so it can only be initialized. Later on you cannot assign it any other value. Similarly, this is a function, and here we are specifying that this function, it takes a constant reference as an input. So we'll talk about reference and constant references later on. This is a function. This is basically declaration as well as definition of the function. This is both the declaration as well as definition of the function. Okay. So declaration, there are other kinds of declarations. We can declare namespaces as well. We can declare types, user-defined types as well. User-defined types can be declared using structs, classes, and enumerations. In this course, we will learn about structs and maybe enumerations later on. Classes we'll study in object-oriented programming, in the course on object-oriented programming. We won't be declaring namespaces, but we will look at the declaration of namespaces here in this lecture as well. Actually. Okay, so what are header files? And a header file, we have talked about it again. This is just a repeat in a more formal context. Header file and the preprocessor. So a header file is a file that holds declarations of function types, constant, and other program components. So if you're defining new types, declaring, if you're defining or declaring new functions or constants, so you put all those declarations in a header file. That is what the header file is for. And then you include that header file into your program. How do you do that? You do it using this construct. The hash includes, say, for example, IO stream. It is a preprocessor directive. What is a preprocessor? A preprocessor is basically part of your compiler. It is a software, it is a part of your compiler, and this is a directive or instruction to this preprocessor. What does this instruction say? It says, okay, locate this header file on the hard drive and copy its contents into your program, into this source file that you're working in. Okay? So it adds the declarations to your programs. Declarations from this file are copied into our program. Typically, the header file is simply a text file. So it is simply a text file. It is not a data file as we mentioned before. It is simply a text file. A header gives you access to functions types that you want to use in your program. So a header basically gives us access to the interface. All the data types, the new types or data types, the user-defined types, the functions, the constants, everything is accessible to us. Their declarations are accessible to us. So usually we are interested in the declarations and not their definitions. We want to just use them. We don't want to understand how they were implemented. Okay? The actual functions, types, etc. are defined in other source code files. So the actual definitions are in some other source code file, and usually they are part of library. Okay, so this is about header files and the preprocessor. So we have briefly talked about it before as well. This is a more formal introduction to these files. So the brief introduction was when we were beginning or learning how to program. So now you have some idea about functions and constants and variables and types and all these things. So now, like, you would be in a much better position to understand what the header file is all about. That's why we have more formal um, um, information about the header files here in this part of the lecture. So we've talked about this one. We mentioned the term scope in a previous slide. So we said that a scope is a region of a program text or program code. Program text refers to program code. So the code that you're writing, so scope is basically a region of that code. Okay. Now there are different types of scope. There are different types. Global scope, we talked about that. Talked about the global scope. If you declare a variable outside any language construct, like it is when we say language construct, so you can think of it like outside any pair of curly braces. If you declare a variable outside any pair of curly braces or any parenthesis, so that is outside any language construct. And that variable has a global scope. We'll learn about it through an example, okay? So that variable has global scope. Class scope, we'll learn about it when we talk about classes, okay? So let us just forget about this thing. Just remember that variables can have class scope. Just remember that variables can have class scope. So when we are writing our own classes, then you will be in a much better position to understand what class scope is. Local scope. This is important. You should understand, you should clearly understand these three types of scopes: global scope, local scope, and statement scope. Local scope means that the scope of the variable or the variable can be seen between a pair of curly braces. Okay. So whenever we say scope has something to do with your ability to see a variable. Okay. Of course, you can see all the variables, but can your compiler see that variable? So that has to do with scope. ठीक है ना? Telescope, microscope, scope देखने से ताल्लुक है. So स्कोप से मुराद आपके प्रोग्राम का वो हिस्सा जहाँ पे कोई वेरिएबल आपके कंपाइलर को नज़र आता हो. अगर आप उस वेरिएबल को या उस नाम को उस स्कोप में या उस रीजन में इस्तेमाल करते हैं तो आपका कंपाइलर आपको एरर नहीं देता, आपको ये नहीं कहता कि जी ये नाम डिफाइंड नहीं है फॉर दिस स्कोप. ठीक है. सो दैट इज़ व्हाट वी मीन बाय स्कोप. एंड देन वी कैन हैव स्टेटमेंट स्कोप. ठीक है. Statement scope means कि there is a variable and that variable is visible only in a particular statement or a particular construct. ठीक है. Outside that construct it is not visible. So we look at that as well. A name in a scope can be seen from within its scope and within scopes nested within that scope. ठीक है ना. ये लफ्ज़ों में तो बड़ा complicated, it sounds like very complicated, but it is very simple. If you declare a name in a scope, so that name is visible from within that scope and from within the scopes which are nested in that scope. अच्छा, इससे क्या मुराद है? I guess we should go to an example. ठीक है. अच्छा, and this applies only after declaration of the name. If you have declared the name, only then can you basically use that name. Before declaration आप किसी भी नाम को इस्तेमाल नहीं कर सकते. ठीक है. I guess let us create a program and then let's see ये जो बातें हम कर रहे हैं कि स्कोप के हवाले से. अच्छा, this is computer programming. ठीक है. Sources and then this is 17th July and then functions and sorry 17th July functions and scope. Okay, select the folder. ठीक है. Let us name it as functions and scope. Let us create this project. अच्छा जी. So this is the source code that we have by default. Now, first of all, we said something about global scope outside any language construct. If you declare a variable outside any language construct, that variable has global scope. It is visible in all parts of your program. For example, let us declare a variable here. Let us say int x is equal to say 10. Now this variable is defined outside any language construct. It is outside any function, outside any loop, any if-else structure, outside everything. It is at the file level. Now this is a global variable. ठीक है. Global variable. It will be visible everywhere. It is visible here in the main function. ठीक है. अच्छा, let us print this variable x. So let us say uh, x is equal to and then print the value of x. Print the value of x. ठीक है. We have not declared x here in the main function. We are just using it. ठीक है. We are just using it. We have not declared x here in the main function. We are using it directly without declaration. Why? Because we have a global declaration of x here. So we have a global x which is declared out and defined outside any language construct. Okay. So we have a global x here. So this is how you can create global variables. Now you can create global variables. You can declare global variables, but you should never do that. You should not be doing it very often. Global variables can result in many problems. Okay. So let us build and run this code. and here you will see you can use you can access the global variable x in the main function, okay, although it is not declared in the main function. Actually, it is taking quite some time. So here are the results. X is equal to 10. Okay, so you can access it here. Let us create a function. Okay, for example, let us create this function int uh, function int function. What is this function? Let us call this function as what? Say let us call this function as cube. This is function cube. Okay, and function cube takes an input argument x. Okay, acha, let us create another function. Take a void print. Let us create a function void print. Okay, so what would this print function do? Void means this function returns nothing. Okay, void means nothing. Void print means that print is a function that would return nothing. It does not return any output value. There won't be any return statement in the print function. Okay, that is what void means. Let us define. This is declaration of the print function. It basically tells you what is the name of the print function, what are the type and number of input arguments, what is the return type. Okay, that is what the declaration or function prototype tells you. Let us define the print function. This is the definition of the print function where we provide the implementation of the print function. ठीक है? अच्छा, यहाँ पे हम क्या कर रहे हैं? Here we are printing x. ठीक है? We are printing x. Okay, so x, we have not declared x in this function. Inside the print function, we have not declared x, but we are printing it. ठीक है ना? We are using this name x. How can we use this name x? Because x has global scope. X has global scope. X is declared outside any construct. Okay? So it has global scope. It can be accessed from the main function, from the print function, from any other function inside this in this file. Okay? Acha. So let us execute the print function as well. Call print function from here. So this is how we call the print function. Okay? Print, and then it does not take any input argument and it does not return any value. Okay? So we cannot say cout print. That would not make any sense. Cout print. This would be in fact an error. Why would it be an error? Because print does not return any value. Okay? Print does not return any value. So you cannot print it. So you should just call it print. And build and run. Okay? So let us make some difference between this is inside print function. Okay? This is inside print function. So once you inside main, this is from inside main and this is from inside print. Okay, na? So we are accessing the same variable. Now let us comment this declaration out. Okay, na? Now x is no longer a global variable. Okay? So if x is not a global variable, so here this statement, this is going to result in an error. Why? Because x is an undefined name within this scope, within this scope of function main. This is undefined. Similarly, this variable x, it is undefined. it is undefined within the print function, within this scope. ठीक है ना, within these pair of curly braces this is undefined. अच्छा, let's first see कि ये it gives us an error or not. Okay, so x was not declared in this scope. So the compiler does not know what x is in this scope. This is the scope or region of program that your compiler is talking about. ठीक है? अच्छा, similarly in function void print, x was not declared. This x was not declared. ठीक है? Now in order to fix these two errors, you need to declare x here separately and x here separately. If you make a declaration here, if you say int x is equal to 20, say for example, then this declaration will fix this error. Now x will no longer be undefined in this scope in main function. This would still be an error. If you compile this code, okay, so now the only error that you get is x was not declared in this scope. X is undeclared in this particular scope in the function print. So you need to define x here as well. You need to say int x is equal to say 30. Now these two x's, this x and this x, these are two different variables. They will be assigned different spaces in RAM and different values. Like they have different values. They can have same values, they can have different values, doesn't matter. In this particular case, there was only one variable x. Here we will have two different variables x. This x is defined in the scope in the main function, and this x is declared and defined in the print function. So these are two different variables. Okay. Let us compile this code and then build and run it. Okay, so x is equal to 20 and inside print x is equal to 30. These are two different x variables. That is what we mean by scope. This variable x is defined within this scope. Okay, and similarly this variable x is defined within this scope. Asha. Then we said something, okay, a name in a scope can be seen from within its scope and within scopes nested within that scope. What do we mean by that? So for example, let us come here. Say for example, let us create a for loop here. ठीक है ना? Let us create a for loop here. So for, and here I'm using the variable I as loop counter. Int I is equal to 0 and I less than 5 plus plus I. ठीक है? And here what we are doing is we are just printing this thing, cout, uh, just this character asterisk. ठीक है? So this will print a single line of 5 asterisk characters. ठीक है? After this, say we print out the end line, and I'm not going to call print function so that we understand what do we mean by here. What do we mean by this? Now this here is another scope. This pair of curly braces, this basically creates another region in your program. Okay, how does that? So this is one scope and this is another scope. So this for loop is inside the main program. Okay, so this region or this scope is nested within this region. It is inside the main function or the main subroutine. So it is nested within the main function or main subroutine. ठीक है? Now if x is visible inside this scope, it would also be visible inside the scope that is nested within this scope. ठीक है ना? So इसका मतलब ये है कि x would also be visible here. X would also be visible here. So you can print out x here as well. ठीक है? Or you can access x here. For example, let us increment x. So after we are done with this loop, so x should be changed. It would no longer be equal to uh, 20. It would be equal to 25. Okay? So how can we access x? Because x is visible within this for loop. ठीक है? So we have this region, the main function. This is one scope, and then we have the for loop. This is another scope, but the for loop is inside the main function. So this scope is nested within this scope. ठीक है? And that's why if a variable is declared in the outer scope, so it is visible in the nested scopes. Okay? But this is not true vice versa. For example, integer I, it is declared within this for loop, within this for statement. So I is visible only here. I is visible only within this statement and this for loop. Here you can see I. Outside this statement you cannot see I. So first let's check this behavior कि ये काम करता है या नहीं, और उसके बाद हम वो दूसरी possibility देखते हैं. The code compiles fine. Let us build and run it. So when we declare and initialize x to 20 and then we print x, so this is the output for that, x is equal to 20. Then this for loop, it prints the asterisk character 5 times and it increments x as well. So once we are done with this loop, we print the value of x and we get x is equal to 25. ठीक है? तो x यहाँ पे visible है. That's why आपका compiler ने आपको error नहीं दिया और आप x को increment कर सकते थे. ठीक है? अच्छा. Now let us do something else. यहाँ पे let's see, we want to know what the value of I is. ठीक है ना? So let's say we want to print I. I is equal to I. ठीक है? Now I is declared. I की declaration मौजूद है यहाँ पे. ठीक है? But I is declared within this statement. It is declared inside this statement for the for loop, where we declare the counter, loop counter, and provide the continuation condition and the modifying statement. So I is declared here. Now just because of this declaration, the scope of I is only these two, this region. This is the scope of I. So I is visible here and in this region. Outside this region, I is not visible. So this statement would give us an error. The compiler would flag an error that I is undefined here. I is undefined in this scope. So let's see if that is the case. Compile it. Okay? So the compiler gives us an error that I was not declared in this scope. That means that this scope and this scope, these are two different scopes. These are two different regions. Okay? This scope is nested within this scope. If you declare a variable in the nested scope, it is not visible outside. If you declare a variable outside, it is visible in all the nested scopes within that scope. Okay? That is the point that we wanted to make here. That is the point that this statement makes here. So what are the benefits of scope? A scope keeps things local, and local scopes are better. You should prefer, or you should be using local scopes. Keep your variables as local as possible. Okay? Do not go for global variables. Global variables may make things easier, or it may seem that things have become easier, but they can complicate the debugging process. You can run into bugs that would be very difficult to find in your code. So, and locality is good because when you keep things local, one function cannot mess up with the data of another function. Okay? So your variables and your functions can only work, your functions can only work with your variables. They cannot interfere with the variables of other functions. So real programs have many thousands of entities, and in that case, locality is good. You should always keep things as local as possible. Okay? So this is what you should know about. I hope you understand statement scope as well. So the loop counter for the for loop I, it had statement scope. It was visible only inside the for loop. Outside the for loop, it was not visible. Okay? That is what we mean. So you know what global scope is. We have looked at it. You know what local scope is. Another thing that I want to mention here is it is this thing. For example, we have these two declarations. Okay? This is a global variable x. Its value is 10. And this is a local variable x inside main, say. Okay? This is, let me comment out this line. So we have a global variable x which has been initialized to the value 10. Now this variable x is visible inside the main function. It is visible inside the print function, everywhere. Okay. Acha. When you enter the main function, you declare another variable x by the same name. This is a local variable x, and its value is 20. Now here you're printing x. You say x is equal to, and you're printing x. So which variable would be printed? The local variable x or the global variable x? So you should always remember that the local variable shadows the global variable. The local variable shadows, covers the global variable, hides the global variable. So when you're printing x here, it would print the local variable x. So you'll get x is equal to 20. So this would be the local variable x. And for example, inside the print function, if you do not have this local variable and you call the print function, okay, so then it would print the global variable x. It would print the global variable x with the value 10. So you can verify that. This is you should know this about this technicality about global and local variables as well. If you have a global and a local variable of the same name, so the local variable would always shadow the global variable in a given scope. Okay? So let us compile it. This is not considered as a redefinition. Okay? You would think we are trying to redefine the same variable. We are not redefining the same variable. Redefinition means redefining the same variable in the same scope. These two variables have different scope. This variable has global scope and this has local scope. So you can always, we cannot redefine x here. Okay, so that would be an error. If we try to redefine x in the main function, then we are trying to redefine x two times in the same scope. But here we have a global x and a local x. Okay? So the scopes are different. So this is not considered as redefinition. If you build and run, so here you would see inside the main function when you print x, so the local x is printed. And when you call the print function, there the global x is printed. Why? Because there is no local x there. We have removed this declaration of the local variable x. So here the global variable x is printed. So you should always know, okay, a local variable shadows the global variable. Okay? Achha. So I hope like you have a very clear idea of scope, local scope, global scope, and statement scope. Okay, so you know all these scope. Class scope, you should know the name or the type कि ये भी scope की एक किस्म है. But we learn more about it in the course on object-oriented programming when we are actually writing our own classes. अच्छा, so this is about nesting of scopes, ठीक है? So scopes के we have demonstrated it. They have just created this block, and we did that with the for loop. Okay, so they just created this block. So this is another local variable x. This x and this x, these are two different x's. Okay, these are two different x variables. So you can try it. Uh, you can try this code on your own, but you should always avoid such complicated nesting or hiding. Keep things simple. That is a very basic idea in programming. You should always avoid very complex syntax or writing very complex statements. You should always keep things as simple and as straightforward as possible. Okay, so now we'll continue our discussion about functions. Let us recap why we wrote functions in the first place. So we said that functions, they allow us to chop a program into manageable pieces, divide and conquer. Divide and conquer is a very important strategy in solving problems using computers. You take a big problem, you divide it into small sub-problems, and then you write solutions or functions that basically solve or compute each sub-problem. And then you combine those solutions and you end up with a solution to the bigger problem at hand. Okay? match our understanding of the problem domain. So you basically divide a problem or anything into logical operations, and then a function, you write function for each logical operation. Okay, so every function is written so that it can do just one thing very well, and then you combine those functions and you solve the bigger problem. Okay? Functions make our programs easier to read. You divide, you like one reason why books are divided into chapters is like they divide the book into manageable pieces, and those pieces, like, they are logically different from each other. They address different aspects of a certain topic. So the same is the case with functions. Each function is there to solve a particular sub problem or problem. So it allows you to write programs or create programs that are more easy to understand and more easy to read. Okay. Similarly, a function is something that can be useful in many places in a program. So instead of writing the same code over and over again in different places, what you do is you write it once and make it a function, and then you can call that function again and again. Okay, so it saves you time as well. It makes testing easy, testing your code, and it makes distribution of your code easy, and it makes maintenance of your code easier as well. Okay, so what you should do is you should keep functions as small as possible, as specific as possible. If you have a very specific job or thing to do, so you can write a very clean and clear function for that. That will make things easier to understand, specify, and debug. Okay. So we learned about the general form of functions. What you do is you specify a return type. Every function, it is basically written to return some value. There some functions may not return a value. Okay, so we can say those functions return a void or nothing. Okay, so we have written a function print that basically returns nothing. It prints something. It does something, and by looking at the output or some other thing, it shows like it has done something. So this is the general form. We specify the return type, we specify a name, and then we specify arguments, inputs to the function. This is the declaration of a function. We end the declaration with a semicolon. And if we want to define a function, we repeat the same return type, name, and the input arguments, and then we provide a body of the function. The body of the function, an example is this function. So this is a double f function. It returns a value of type double. Its name is f. It takes two input arguments, a and d, and it returns the product of those two input arguments. That is what it does. This is a definition of this function. The arguments to a function are also called parameters. You can call them inputs as well. Okay? Arguments, parameters, or inputs, they are one and the same thing. And you specify these as a list. So the list is specified as type and then name, type, name, type, name, type, name, separated by a comma. So just like here, for example, here we have the print function. It does not take any input argument. For example, if you want to write another function, say for example, int what? Int average, say for example, we want to find the average of three numbers. So the average would be a floating point value. Okay? So you can say float average, and we can find the average of three values. So you specify those three values as a list. And how do you specify that list? You specify the type and the name, the type and the name, the type and the name. So this is a list, and each input is separated by a comma. So this is one input of type integer, this is another input, this is another input. Okay? So this is how we do it. So you have done it. We have done it in our last lecture. Here we will talk about something else. If you don't want a function to return any value, you can set the return type as void. Void means nothing. Void means nothing, or it basically says that this function does not return a value. So just like the print function here, so the print function does not return a value. By the way, if there is a function that does not return a value or the return type is void, we don't call it a function. Some people prefer to call it a subroutine. So they tend to differentiate between a subroutine and a function. A subroutine procedure and a function procedure. A function procedure returns a value. A subroutine procedure does not return a value. Okay? Achha, so this print subroutine, this is a subroutine. It does not return any value. It returns nothing. Okay? There is no return statement here. So this is a print subroutine. Similarly, we also know like what is the body of a function. Okay? Body of function is a block of code basically, and you specify or write that block of code or create it using a pair of curly braces. Okay? Why do we write functions? Functions represent implement computations or calculations. If you want to do a specific computation or calculation, you write a specific function for that. You call that function and that computation is done for you. Okay? So this is a recap. This is what we did last time. Now, here is the new thing in this lecture. This is important. You should know and understand these things. One, when you call a function, so you pass input arguments to that function. Okay? You pass input arguments to that function. Now, those input arguments are passed using two different ways. Okay? Using two different ways. Let me I'll comment out some code and then I will demonstrate something to you. For example, we have this average function, okay? And let me comment out this code as well. I just want to talk about that, okay? Acha ji. So let us write the average function first. Let us define the average function. This is the declaration of the average function. Let us define it. Achha. This is how you define it. So I copied it, the declaration from there, and now I'm trying to define it. So how do you define the average function? The average function would calculate the average of A, B, and C and return that value. How do you calculate the average? You sum these values and divide it by 3. Okay, so you can say return, and then you can say A plus B plus C, and then you can divide it by 3.0. Achha, why am I dividing it by 3.0? Why not 3? If I divide it by 3, then the numerator a plus b plus c is an integer and the denominator it is also an integer. Okay? This is an integer constant. So then integer division will take place. That means we will lose the remainder. Okay, so but if you want to retain the remainder, so you can make one of the arguments, either the numerator or denominator, as a float or double value. Then real division will take place. Okay, floating point division will take place, and you will get a floating point value or a real value as the answer. So you can return that value. Okay. So this is how the average function would work. Okay. Acha. Now we can call the average function from the main function. So let us declare 3 variables here. Let us say int x, y, and z. These are 3 variables. Acha. And let us assign these variables some value. Uh, let us assign, for example, let us ask the user to enter 3 integer values. Okay? Please enter 3 integer values. Okay? So we are asking the user to enter 3 integer values, and then we are reading those integer values, x and then y and then z. Okay? Acha ji. Now we want to find out the average and print the average. Okay? So we say cout uh, the average of x comma y comma x comma y and z, and z is z is so let us call the average function average, and let us give it these values x, y and z. Okay, so we are calling the average function here, and we are passing it these the values stored in the variables x, y and z. Okay, so the question is, how would these values be transferred to the function average? ठीक है, यानी फंक्शन एवरेज को जब कॉल किया जाएगा तो a में x की वैल्यू होगी, b में x की वैल्यू होगी, c में x की वैल्यू होगी. ठीक है, सो ये जो हम कॉपिंग कर रहे हैं, ये जो हम एवरेज को कॉल कर रहे हैं और x, y और z की वैल्यूज पास कर रहे हैं, सो दीज वैल्यूज विल बी पास्ड बाय वैल्यू, और these arguments will be passed by value. These arguments will be passed by value. इससे क्या मुराद है? इससे मुराद है कि x, y और z की कॉपी बनाई जाएगी और वो कॉपी पास की जाएगी टू वेरिएबल a, b एंड c. ठीक है, सो a, b एंड c ये डिफरेंट वेरिएबल्स होंगे, x, y एंड z डिफरेंट वेरिएबल्स होंगे. x, y and z, these variables would be different, and a, b, c, these variables would be different. They would be allocated different places in random access memories. ठीक है, a, b and c would hold copies of x, y and z, copies of x, y and z. ठीक है, इसका मतलब why are we talking about that? इसका मतलब ये है कि अगर हम यहाँ पर a, b और c को चेंज करें, यानी from inside the main function, if we do something like this, a is equal to 10 or b is equal to, for example, 30 and c is equal to 50, if we do something like this, that will not change x, y and z. It will not affect x, y and z. ठीक है ना, हमने एवरेज को x, y and z की वैल्यूज पास की हैं और वो वैल्यूज उनकी कॉपीज आती हैं टू द फंक्शन एवरेज. वो कॉपी आती है इन वेरिएबल a, b and c. a, b and c, these are separate variables. If you change a, b and c, this change will not affect x, y and z. ठीक है, that is what we mean. अच्छा, we are not going to do this. We want to find out the average. ठीक है, so let us compile this code. X was not declared in the scope. अच्छा जी, let us comment out, और इसको comment out करने के बजाय let us declare X. अच्छा, let us compile this code. It runs fine. Let us build and run. Sorry, it compiled fine. Let us build and run. Enter three integer values: 25, 63, 52. The average of 25 is 46.667. ठीक है, it calculates fine. अच्छा, the point that I wanted to make was कि x, y and z and a, b, c, these are different variables. ठीक है, so let us verify how are these different variables. You'll learn something new in the process as well. So for example, the address of x, every variable when it is allocated space in RAM, it has an address, it is assigned an address in RAM as well. So you can print out the address of a variable. ठीक है, so if we want to print out the address of x, for example, if you want to know about the address of x, so the address of x, you can get it by using the ampersand operator. So you can say address of operator, you can call it as the address of operator, address of x. This will print out the address of x. ठीक है, so this will print out the address of x. Similarly, if you want to print out the address of y, so you can say address of y is equal to and address of y. So this is the address of operator. You give it some variable as an argument and it basically gets the address of that variable in RAM. And address of z. So the address of z would be, we can get that address using the address of operator. Now let us repeat the same thing for A, B and C. Let us do the same thing for A, B and C. Now if A, B and C and X, Y, Z, these are different variables, so their addresses would also be different. ठीक है, उनके addresses भी मुख्तलिफ होंगे. If they are the same, their addresses would be the same. So इससे हम क्या साबित करेंगे? इससे हम ये साबित करेंगे कि जी A, B and C, these are different variables than X, Y and Z. और उससे क्या साबित होगा? उससे साबित ये होगा कि जब हम फंक्शन एवरेज को कॉल करते हैं तो फंक्शन एवरेज को एक्स, वाई और जी की कॉपीज़ पास की जाती हैं और वो कॉपीज़ वेरिएबल्स ए, बी और सी में रखी जाती हैं जो कि सेपरेट वेरिएबल्स हैं. ठीक है. अच्छा, दिस इज़ व्हाट वी वांट टू प्रूव बेसिकली कि when you declare a function like this, when you declare a function like this, so this declaration means कि ये जो वेरिएबल a है, b और c, these are inputs to the function average. These inputs will be transferred or passed by copy, by value. यानी अगर आप इस एवरेज फंक्शन को कॉल करेंगे तो यहाँ से अगर आप कोई वेरिएबल प्रोवाइड करते हैं या कोई कांस्टेंट, उसकी कॉपी बनाई जाएगी और वो वेरिएबल ए, बी और सी में स्टोर की जाएगी. So these two variables x, y, z and these variables a, b, c, these would be different sets of variables. ठीक है. This is called this is called pass by value. This is pass by value. ठीक है. हम variables arguments pass कर रहे हैं to a function by value by making copies. ठीक है. So let us build and run and let us verify कि ऐसा ही है इस तरह के हम कह रहे हैं. So enter three integer values, say 45, 98, 71. Now if you see address of x is this is a hexadecimal value. ठीक है, ये hexadecimal format में है. 61FE0C, address of y 61FE08, address of z 61FE04. अच्छा, यहाँ पे फिर अगर आप देखें ना, एड्रेस ऑफ A that is 61FDE0, it is different than x और इसका एड्रेस सेम नहीं है. एड्रेस ऑफ B is 61FDE8, ठीक है ना, it is different than y, and address of C is 61FDF0, this is different than Z. So that means like x, y, z and a, b, c, these are different variables. x की कॉपी बनाई जाती है और वो कॉपी आती है a में, फिर y की कॉपी बनती है और वो कॉपी जाती है b में. यू कैन वेरीफाई दैट. अगर आप इनकी वैल्यूज प्रिंट करें यहाँ पे कि a, b और c क्या हैं, so you can verify that. ठीक है. So you can verify c out, you can say कि a is equal to and then a, और इनफैक्ट ये अच्छा चलिए यहाँ से दोबारा लिख लेते हैं. सी आउट a is equal to and then a, अच्छा फिर कॉमा b is equal to then b and then comma c is equal to and then c. So a, b और c में वैल्यूज़ वही x, y, z की होंगी. ठीक है, बट ये तीन मुख्तलिफ वेरिएबल्स हैं अदर देन x, y एंड z. अच्छा, so a contains 47 जो x की वैल्यू है, b contains 89 जो y की वैल्यू है, c contains 63 जो z की वैल्यू है. But these are three different variables. X and a are different, y and b are different, z and c are different. So what is the point that we want to make here? The point that we want to make here is कि ये जो inputs आ रही हैं to the function average, these inputs are passed by value. यानी जो वेरिएबल आपको आगे आ रहा है, भिजवाया जा रहा है, वो ओरिजिनल वेरिएबल की कॉपी है, उसकी वैल्यू की कॉपी है. ठीक है, एक्स वाई जी की कॉपीज आगे आ रही हैं, एक्स वाई जी बजाते खुद नहीं आगे आ रही. ठीक है. अच्छा, now there is something else that there's another way of passing values to a function and that is passed by value. So यहाँ पे ये example है in this on this slide. This is called by value. If you are calling this function f and you passing it some value a, जैसे कि हम यहाँ पे पहले f को पास कर रहे हैं वेरिएबल xx की वैल्यू, तो xx दिस इज xx वेरिएबल, उसकी कॉपी बना दी जाती है और वो कॉपी कर दी जाती है इनटू a. a एंड xx दीज आर टू डिफरेंट वेरिएबल्स. ठीक है. अच्छा, फिर हम f को कॉल कर रहे हैं और उसको पास कर रहे हैं वेरिएबल yy. सो yy वेरिएबल की कॉपी बनाई जाती है. yy है 7 its copy is created and is copied into the variables a, ठीक है, and then the function f is called, ठीक है, तो function f जो है वो a को यूं access करता है. So this is called by value. This is called by value. A function, when you call a function and you pass it some input value or argument, basically the function receives a copy of the argument's value. Okay? It receives a copy of the argument's value. And this copy is maintained in a separate variable. This copy is maintained in a separate variable. A is separate, y is separate. If the function modifies, the function f has access to a only. It does not have access to y. If the function decides to modify a, that will not affect y. If the function decides to modify a, it will not affect the value of xx, okay? Because it does not have access to the variable xx. It only has access to the variable a, which stores a copy of the variable xx. This is called by value. This is the default mechanism of passing values to a function. The other way of passing value to a function is called by reference. Called by reference. Now, whenever you hear the word reference, reference means an address. So when you are calling a function, instead of passing copy of the value to that function, you pass the address of the argument to that function. ठीक है? So here, for example, we have the function f, और यहाँ पे हमने ये specify किया हुआ है कि function f is receiving a reference as an input. ठीक है, तो इसको आप एड्रेस भिजवा रहे हैं as an input. ठीक है, now फिर फंक्शन f जो है ना, अब उसके पास एड्रेस आ रहा है आर्गुमेंट का, वैल्यू नहीं आ रही है या वैल्यू की कॉपी नहीं आ रही है, उसके पास एड्रेस आ रहा है. दैट इज अ लिटिल डेंजरस. ठीक है, फॉर एग्जाम्पल व्हेन यू कॉल फंक्शन f हियर, सो अब फंक्शन f को आप आर्गुमेंट भिजवा रहे हैं xx, तो xx जो है उसका उसका बेसिकली a जो है इट कंटेन्स एड्रेस ऑफ xx, यानी xx की कॉपी नहीं बन रही, बल्कि xx का एड्रेस a के पास जा रहा है. ठीक है, a में xx का एड्रेस जा रहा है, तो उसका असर नेट रिजल्ट क्या होगा कि नाउ फंक्शन f हैज एक्सेस टू द वेरिएबल xx, इट कैन चेंज xx. A copy of xx is not being made. ठीक है, the address of xx is passed to function f. So now a is basically xx. A is just another name for xx. A is an alias for xx. And a function f जो है वो xx वेरिएबल को a के नाम से पुकारेगा. तो जब वो कहेगा कि a is equal to a plus 1, so that will change the value of variable xx. ठीक है, सिमिलरली जब आप उसको दोबारा कॉल करते हैं और आप उसको y पास करते हैं, तो y अभी आपने यहाँ पे स्पेसिफाई किया इट विल बी पास्ड बाय रेफरेंस, तो y का एड्रेस a में जाता है. ठीक है, सो फंक्शन f हैज एक्सेस टू द वेरिएबल a. अच्छा, लेट अस लुक एट इट एज एन एग्जांपल. यहाँ पे हमने जो कोड लिखा है उसमें हम इसको देख लेते हैं. अच्छा, सो फर्स्ट ऑफ ऑल लेट अस लुक एट द आइडिया ऑफ रेफरेंस. रेफरेंस है क्या चीज़? ठीक है, let us do that. अच्छा, in order to do that, let me comment out this code first. Let me comment out this code first. Achha. So let me declare two variables. One is int a is equal to, or say int a, and the other is int, and here I say ampersand b. Okay. Now this a, variable a, it is a value type. What do we mean by that? It stores a value. It stores a value. And this b, this is a reference type. Reference type. Okay. What do we mean by that? It stores a reference or an address. It stores a reference or an address of another variable. Now you can say something like this. You can say a is equal to 100. This is perfectly fine. But you cannot say b is equal to 100 or 200 for that matter. This would give you an error. Let us see if it does. It should. Okay? Yes, b is declared as a reference. Okay? But not initialized. Acha. This statement, it didn't give us any error. let us initialize it. Say for example, अच्छा, ठीक है. So this is illegal. This should be illegal. अच्छा. Uh, this is fine. A is a value type. You can assign A any valid integer value. ठीक है. B is a reference type. So the best you can do is you can assign it the address of another variable. You can say B is equal to A. You should be able to do that. Achha, but not initialize. We need to do it here. We can say B int reference B, and we need to initialize it here. So we can assign it A. We cannot do it here. ठीक है. This we can do. Int A and int ampersand B. This is basically a reference B. So this is B is now a reference. It is not an integer, but it is a reference to an integer. It will store the address of another integer. ठीक है. Acha, we will elaborate this a bit more, but just hold on for a second, few seconds. Okay, so now this would compile fine. Acha, this compiles fine. Now can we initialize it with some constant value? Say we want to initialize it with 200. We should not be able to do that. Okay, we cannot do that. We cannot initialize a reference type with a constant value. We can do this for this thing. We can say int A is equal to 100. We can do that. Or 200. ठीक है, we can do that. इसको भी comment out करें. This is fine. This is not. Why is this not fine? ठीक है, this is not fine because B is a reference type. B stores the address of a variable of type integer. So you can only initialize it with some integer variable. You can say int ampersand B is equal to A. So now B will have the address of A. B will have the address of A. ठीक है, B will have the address of A. So this is fine. अच्छा, what do you mean by B will have the address of it? So you can think of it as कि B जो है, it has become an alias for a second name for A. Alias से मुराद क्या है? उर्फ. जैसे एक रियल बंदा होता है ना, फॉर एग्जाम्पल व्हाट कैन उर्फ यूजुअली, जैसे गुलाम मोहम्मद उर्फ गामा, गामा पहलवान. ठीक है. So they are two different names for the same person. So similarly, B and A, these are two different names for the same variable. When you do this, when you make this declaration, you're not creating a new variable. You're not creating a new variable. आप नया variable नहीं बना रहे. It is the same variable A जिसके लिए आपने एक नया नाम बना लिया. ये कैसे? You can verify it. You can say number one, C is number. Let us print the value of A. So A is equal to A, and similarly let us print the value of B. B is equal to B. So you will get the same value. ठीक है? You will get the same value 200. दोनों cases में A is equal to 200, B is equal to 200 print होगा. Then let us change B. Let us say B is equal to 500. ठीक है? अच्छा, फिर A और B को print करें. So now you'll notice कि A और B दोनों 500 हो गए. A भी 500 है, B भी 500 है. ठीक है? अच्छा, फिर आप कहें जी A is equal to 800 और देन प्रिंट A एंड B. So दोनों A और B 800 हो जाएंगे. ठीक है. ये कैसे? ये उसी वक्त पॉसिबल है जब A और B दोनों एक ही वेरिएबल को रेफर कर रहे हो. ठीक है, ये दोनों एक ही वेरिएबल के दो नाम हो, ये तभी पॉसिबल है. ठीक है. तो यहाँ आप देखें int A is equal to 200. A को हमने डिक्लेयर किया, इनिशियलाइज किया विद द वैल्यू 200. देन वी डिफाइंड अ रेफरेंस. दिस इज अ रेफरेंस. B is a reference of type integer. That means it will store the address of any integer. Integer reference को initialize करने का तरीका ये है कि you have to initialize with some variable of type integer if it is a reference of type integer. अच्छा, फिर हम A और B को प्रिंट कर रहे हैं. दोनों केसेस में A is equal to 200, B is equal to 200 प्रिंट हो रहा है. ठीक है. देन वी आर मॉडिफाइंग बी, वी से बी इज इक्वल टू 500, बी को मॉडिफाई किया लेकिन ए भी चेंज हो गया। जब हम कहते हैं ए इज इक्वल टू ए, तो ए भी 500 प्रिंट हो रहा है, बी भी 500 प्रिंट हो रहा है। फिर हम ए को चेंज कर रहे हैं, ए को असाइन कर रहे हैं द वैल्यू 800। सो उसको जब हम 800 की वैल्यू असाइन कर रहे हैं तो ना सिर्फ ए बल्कि बी भी चेंज हो रहा है, दोनों चेंज हो रहे हैं। सो हाउ इज दिस पॉसिबल? दिस इज ओनली पॉसिबल इफ ए एंड बी आर रेफरिंग टू द सेम लोकेशन इन मेमोरी। यानी मेमोरी में हमारे पास एक ही 4 बाइट्स की स्पेस है जिसको हम वेरिएबल ए और वेरिएबल बी दोनों नामों से पुकार सकते हैं। सो दिस इज एन एलियस फॉर ए। ठीक है, बी इज एन एलियस फॉर ए, बी इज एन एलियस फॉर ए। अच्छा, अगर आप इनको इनके एड्रेसेस प्रिंट करें, ठीक है, सो द एड्रेसेस वुड बी द सेम। सो एड्रेस of a, variable a, that is address of a, it would be the same as address of the variable b. Address of the variable b. So if you print both these addresses, they would be the same. Okay? So this would further verify that a and b, they are basically referring to the same variable. एक ही variable के दो मुख्तलिफ नाम हैं, ठीक है? Address of A 61FE14, address of B 61FE14. So they are the same. एक ही घर के दो एड्रेसेस हैं, सॉरी दो नाम हैं, एक ही बंदे के दो नाम हैं, जो भी आप इसको समझ लें। तो a reference to another variable is basically an alias to that variable. ठीक है? So this is what we mean by reference. This is what we mean by reference. So जब हम कहते हैं कि int and this is b which is of type reference, जब हम इसको assign करते हैं a, तो basically what we are doing is हम b में a का एड्रेस स्टोर कर रहे हैं। ठीक है, तो b and a they mean the same thing, then they are the same, they refer to the same variable। ठीक है, so this becomes basically an alias for a, b becomes an alias or another name for a। so you can do the same with functions, like you can specify a will not be copied or passed by value, but a will be passed by reference। You can specify that a will be passed by reference। ठीक है, a will be passed by reference। अच्छा, yeah, let us write another function, let us write another function to demonstrate that। ठीक है, so let us write a function similar to the function here। So here we have this function f, which basically returns back the value of the argument। ठीक है, so let us write some dummy function, int dummy। So dummy function gets an integer argument and then it returns the same input argument or whatever it does। ठीक है, अच्छा जी, so in dummy let us define dummy function, let us define dummy function int dummy, and dummy gets an input argument and then it returns this value। First we increment dummy, int a is equal to a plus 1, and then we return a। ठीक है, then we return a। अच्छा जी, so again I hope like you understand the difference between value type and reference type। now let us differentiate between the call by value and call by reference। ठीक है, अच्छा जी, so let me comment out this code as well। अच्छा, here let us define this variable x, int x is equal to say 10। ठीक है, अच्छा, so let us first print the value of x, x is equal to, and x, then call the dummy function। ठीक है, so let us call the dummy function dummy is equal to, so we are calling the dummy function and passing it the value of x, the variable x as input argument, and this variable will be passed by value. ठीक है, so x पास बाय वैल्यू होगा, इसकी कॉपी बनेगी, वो डमी फंक्शन के पास आएगी, डमी फंक्शन उसको इंक्रीमेंट कर रहा है, यानी a is equal to a plus 1 इंक्रीमेंट कर रहा है. You can do it this way as well. You can say plus plus a, increment a and then return the incremented value, return a. ठीक है, so it will return the incremented value. So here you will get 11, 11 will be printed, but x will remain unchanged. ठीक है, x उससे change नहीं होगा. जब आप x को डमी फंक्शन के कॉल करने के बाद प्रिंट करेंगे, ठीक है, so x would remain the same. This is before calling dummy, this is before, and this is after. So x would remain the same, x would be 10, dummy would return you 11. It is modifying whatever value it is getting, a को ये modify कर रहा है, but since we are passing it by value, यहाँ पे हम इसको pass by value कर रहे हैं, so basically the dummy function is getting a copy of a, and if it modifies the copy of a, that does not affect the original x. ठीक है, उससे कोई फर्क नहीं पड़ता. Let us verify that. Build and run. So before calling the dummy function x is equal to 10, the dummy function increments x by 1 and returns that value, and increments the copy of x, ठीक है, and returns that value, तो वो 11 है. But when once you return, तो x remains unchanged. ठीक है, वो a को change कर रहा है, but changing a does not affect x. क्यों? क्योंकि हम we are calling the dummy function by value, we are passing it a copy of the argument, not the address of the argument. Now if you make one small change, like if you say int and then you make it a reference, ठीक है, now a is of type reference. ठीक है, now you are specifying कि मैं ये जो argument भिजवा रहा हूँ, I am passing this argument by reference. So now when you are calling x, now when you are calling the dummy function, and you are passing it the variable x, so x की copy आगे नहीं जाती, बल्कि x का address pass किया जाता है to the dummy variable, dummy function. And when the dummy function gets the address of x, yani a is now another name for x. When you say increment a, so you are basically incrementing x. ठीक है, so now after you get back from the dummy function, ठीक है, so x would have changed. x पहले 10 था और उसको कॉल करने के बाद वो 11 हो जाएगा. So you can compile this code, compiles fine, build and run. अच्छा जी, ये क्या कह रहा है, undefined reference to dummy. Dummy x, what do you mean by that? See how dummy is equal to dummy x. Undefined reference to dummy x. Why do we have this error? We shouldn't be getting this error. Int a, int xxx. So int x is equal to 10 and we are calling dummy and passing it the variable x. Okay, here we specify, acha, in the definition we did not specify the same. Okay, the definition and declaration both should match. The definition and declaration both should match, and sometimes the compiler may not like point these differences between the declaration and definition. ठीक है ना? Okay, so here before calling the dummy function x is equal to 10, once we call the dummy function and pass it x by reference, so now the dummy function has access to the variable x because we are passing it by reference. So the variable a in the dummy function, that is basically it acts like another name or alias for x. ठीक है? And when you change a, you're changing x. That's why when you get back and you print x again, so now x has changed, it has become 11. Okay? So this is basically passed by a reference. When you're passing by a reference, when you're passing arguments to a function by a reference, you're basically giving that function access to the original variable. You're giving that function access to the original variable. This may be useful in certain situations, and this may be dangerous in certain situations. In certain situations, you may not want to give access to this function. अच्छा एक और चीज़ भी आप याद रखें कि dummy function is receiving arguments by reference. तो यहाँ पे अब आप constant values को नहीं pass कर सकते, ठीक है? You cannot say 200. यहाँ पे you cannot say कि dummy 200. This would be an error. Now, you cannot pass a constant value by reference. You cannot pass a constant value by reference. It must be some variable. ठीक है? अच्छा जी. So I hope you understand the difference between call by value, calling a function by value, and calling a function by reference. In order to understand that difference, you need to understand the difference between a value type and a reference type. So I hope like that example explained it कि जब आप कोई reference type declare करते हैं and you initialize it with some variable, you're basically creating an alias for that variable. So now you have two names to refer to the same variable. ठीक है? So the same happens when you are passing arguments by reference. This function is receiving arguments by value. ठीक है? So जब आप इस फंक्शन को कॉल करेंगे एवरेज फंक्शन को, तो जो भी आप वैल्यू जो भी भिजवाएंगे उसकी कॉपी बनेगी, जो भी वेरिएबल पास ऑन करेंगे उसकी कॉपी बनेगी. दैट कॉपी वुड बी स्टोर्ड इन ए बी एंड सी. ठीक है? And in this particular case, when you're calling a variable, when you're calling a function and passing it arguments by reference, so जो argument आप भिजवा रहे हैं, for example you're passing it x as an input argument, so x की कॉपी नहीं बनती, बल्कि original x जो है, ये वाला जो x है, इसका एड्रेस आगे भिजवा दिया जाता है. Once the dummy function has access to the address of x, so it has access to the variable x, and now it can change x. ठीक है? You should be aware of that. जब आप arguments को pass करते हैं by reference, so you're giving this function the callee function. ठीक है? Main function जो है ये आपका caller function है. It calls the, this is the caller function. ठीक है? और ये जो दूसरे functions हैं, these are callee functions. इनको call किया जाता है from the main function. This is a callee function. ठीक है? So when you call a function by reference, ठीक है? So you're giving that function access to the arguments. ठीक है? इसको prevent, there is a mechanism for preventing that. So we learn about that. I guess this is enough for this particular session. Let's see what do we have here. Okay, so I hope like you know the difference between value types and reference types, and you also know what do we mean by calling a function by value and calling a function by reference. The other technicalities about calling a function by value and reference, so we'll talk about that in another session. I guess this is enough for this particular session. And I hope like with the examples and all these things, we have clarified the difference between value types and reference types, and the difference between calling a function by value and calling a function by reference. ठीक है? So I hope we have done that.